Hi, my name is Gary Taylor, and in this series of videos, I want to demonstrate messaging queues. In particular, I'm going to focus on RabbitMQ, .NET Core, and MassTransit. But first off, this is an introduction and it's also my walkthrough. I'll be doing a number of videos and improving them over time. So this is the very first early days. Now, I've been using messaging queues now and messaging queue systems for around 10 years in production in some of the largest organizations. And people have different opinions about when and how they can be used. And I want to just tell you my take on what I've learned actually using this in anger. But first off, we need to work out what exactly is a message queue. Well, a message queue is a single piece of data that we want to pass on to another person to manipulate, change, and work with. Now, we're talking about business value, and we should always be talking about business value when we're dealing with code. We shouldn't talk about pure abstract information. We should talk to the business about the thing that they want. So let's say someone wants a testimonial system. So when someone adds a note onto the system or changes an application status within your CRM, we send out a testimonial to a customer or a client or an introducer, someone in the business, in that business domain. Or you might have a transaction that's happening. The business is earning income in some way. Maybe they're being given an application or they're completing a transaction like buying an ice cream. You don't want that transaction to get lost. Now, the truth is, with technology, you can never guarantee that something's going to work. You could have a kernel segment fault, blue screen of death on the server as the customer clicks the buy button. You could just have a memory problem, or you just might have a bug in the code. The data means that some code flow, some execution is going to run that's very unusual, and because of that, it hits some buggy code and you get an exception. A great comment is, well, just don't write buggy code. That's just in today's world, you're not writing buggy code on purpose. There is no developer that writes bad code on purpose. Every one of us wants to do a really good job and we want to go home feeling great about the work we've done. We're all that way. So developers do not write crap code on purpose. It's just that it's complex and sometimes there's bugs. You might even have a network problem on your cloud architecture that has got nothing to do with you or your organization. And because of that, you have lost that transaction. That piece of information's gone. And in some cases, your business would never be aware that you've lost that transaction and your company has lost money. So we want to allow a situation where we never lose that transaction. We want it to be fast and scalable and distributed. Well, what does that mean? Well, fast means that we want to take an appropriate amount of time to process that transaction. If a transaction takes 30 minutes to go through, and if the customer cancels at any point, the transaction's lost, you're going to make no money. People are not going to stay on that website waiting for a swirler unless you're selling the latest PlayStation 5. You want it to be scalable. You want to make sure that if you get an abundance of customers on the Monday morning after a big sales pitch on the weekend, you want to make sure all that income and revenue is going to go into your bank account. You do not want a system that collapses because you're doing well. Distributed allows you to take your systems and place them on multiple computers so that it can scale and therefore be faster. And you do that by decoupling data, by decoupling actions from the invoker of the action. But what is the problem we're trying to solve? Is a problem even exist? Well, let's go back to a story of a CRM system. And value has been added to this CRM over decades, and the code has been kept in immaculate condition, which isn't reality. No one has that. But let's say in this perfect world, it has. And every time we add a note or update a customer within this CRM, there's a couple of things we want to do. We want to add a note. We might want to send a push notification to the customer. In certain circumstances, we might want to request a testimonial if they haven't done so, but we don't want to do it all the time. And we might want to send notifications to other people in the organization that a particular action has been invoked. For some reason, marketing want to know, or compliance need to know, or your distribution team need to know that a particular action has been invoked. And here we've got some very clean code. We have got a service that handles these events. There's a delegate that subscribes. So when we call add note, we invoke it and we can do all of them things simultaneously. This code could even be made asynchronous, so it's really quick and easy to run. But the problem is that if you have a development team who needs to change the push and change the add note, you can run into problems releasing that, getting it lined up. You've got your development teams. One team might be working on the send push, one team might be working on add notes, and they might be changing things under the hood. Most of the time, that's related to data in the database, and they get in each other's way. They cause problems, and one mistake in one line of code actually causes all of them services to fail. The other thing is that for an architecture like this, you either release it in one go or there's a problem. So for instance, you might have to release an API, and all of this is behind some website. So you write your code, you test it, and you release the whole website in one go. And if you're trying your best, you might be doing Scrum or Kanban, where there's other features that are being tagged into that release. It's not just one request, one bug fix, one value adding item for the business, and it gets released. You've probably got 10, 20, 30 different things in that one single release. And if they go wrong, you've got to revert them all back or try and fix fast. So even with a really clean service bus type architecture like this, you have still got problems where you can't release when you want, you can't roll back when you want, you can't load balance between two different push services. You can't change this so that the testimonial system goes to Google or then goes to Trustpilot. You've got to update this big monolithic application and release it in one go. So you have also got the code where the button is. In a lot of CRM systems, the code is actually behind the button. If you've got a desktop application, you click the button, thousands of lines of code run, and it's just code layer after layer after layer of these things that have just been added on as the business evolves and the requirements for the business change and grow and get added and mutate over time. The code gets mutated. And no business knows what they want day one. It's an evolving process. Any business that doesn't evolve does not survive. It's just typical that if you do not monitor your customers, monitor your industry, and adapt to change, your business will fail. Don't believe me? Look at Netflix. Sorry, look at Netflix compared to blockbusters. And because of that, your customers or your business does not know what your software is supposed to do. And because of that, you can't write good code because your business doesn't know what you need. So you can't interpret what they need, and therefore you can't write good quality code. So how do we solve that problem? The best way is to separate, to loosely couple things, using solid principles and writing good, clean architecture. But another way is to separate the thing that triggers an action and the thing that does the work. So here we've got the add note action. And what we're going to do is we're going to publish an event and we're going to say, I want to add a note. And we just simply publish it. We do not care how. At this point, it's just behind a button click or it is an API call that's been triggered. We do not care how or what is being done. All we've said is, let's add a note, and here's the note that I want you to send to me. So at that point, you'll have some service somewhere. And this service is a separate, clean, standalone, isolated application. And its only job is to listen to that request and do something with it. So for instance, here we might be listening to the add note. We receive that message. And when we receive that message, we call an event handler and we call a process and that runs some code somewhere. And let's clean that up. Let's clean that thinking. Some system somewhere has raised an event, and that event is to add a note. And then some system somewhere is subscribed to that event. These are two completely separate running applications. Could be in completely different cloud architecture. One could be a desktop application. One could be some latest .NET Core 5, 6 application running in a containerized environment on AWS or Azure. Doesn't matter. This process monitors and listens to that event and runs the action of adding the note into the database and closes and finishes. It's done. It doesn't do any more than that. Imagine if you had a problem with notes and if someone was adding a very long note, you got a truncation error. You come in on a Monday morning, your sprint starts, you know you've got to solve this truncation problem. You've had a chat with your team and you feel the best way is to chop it up into bits and add multiple notes into the system. Changing the size of the database column isn't an option because of your database team. So it's easier to just put multiple notes in and your product owner has agreed and they think it's a good solution to do. You open up your consumer, the thing that's listening to the event, add a note. There is a handful of lines of code. Just takes the message, creates a new note and saves it. If this is Dapper or linked to SQL, you are talking 2 or 3 lines of code. So you write an extension method to split it up into multiple notes. Should it be too small, or well, should the message be too long to fit in the database? And you write it in as multiple notes, stringing them together and making sure that the date, order, and time is correct. You test it, you write unit tests, you write test-driven development and your integration test to make sure it works. You can have a separate database that is just for that one particular service for testing. And when it goes to production, you just change the settings and buff in production now. Should the message be any longer, it then writes into the database. You have clean documentation that explains what the message should look like. You have attributes on there that says its maximum size. You can extend that now. So now we can write a message that's bigger. And we have now explained to the whole business that we now have the ability to handle larger notes. But there's other things that need to be done. Like, for instance, logging. We want to maybe send a testimonial or send an SMS out, send emails. We may even want to call third-party introducers or brokers or clients to let them know that particular action has occurred within the CRM. These things now can start to be split and taken out of the monolithic application. They rows upon rows upon rows of code that's behind that button click or behind that one controller where it doesn't even have its own service, it's just code in the controller. All of that now can be taken out and moved into a separate, clean .NET Core 5, long-lasting support, clean, elegant, and tested, maintainable, and stable. That runs, listens for that event. Your monolithic application simply just raises at the event, and then the subscriber subscribes to it and does the work. So now in your CRM system, you say add a new note, and all the code for the push service and the note service has been taken out and moved into separate monolithic applications. And at the moment, you've decided that the push is going to be its own service, but the note service still has the email, SMS, testimonials, and logging service. It's still a hefty little monolithic application in its own right, but it is an application that only deals with notes. And the reason why we've done that is because the push service might be changing. We might be moving from AWS over to Firebase. We might be changing the way that that works. We might know that based off our code, based off commits, we know that that system changes the most, and we're constantly changing that code. Well, if that's the case, separate it, but only separate it when it's absolutely vital. You might think that splitting the monolithic application means let's take all of these things and chop them up into bits. Think about it. What's the business value? Why should the CEO care? What are we going to get from doing that? Is the business going to earn more money? Are we going to be able to be faster at delivery? Or are we going to waste time actually splitting all of these systems up? And the answer is we're probably going to be wasting time doing it and effort. But if we know that there are certain parts of our system, and this is easy to see by just looking at your Git history, run it through some tools and it can tell you your code path that changes the most. Take that stuff out. Take them features out and move them into a cleaner architecture. The great thing about this is that you could have a really legacy VB application, some monolithic monster, and now you can start writing really clean .NET Core 6 if you're feeling a bit risky. Perfect architecture. Now, obviously, you should have long-term support, so let's stay with 5 or 3.1. But you can write them services and you can write them cleanly and simply and quickly. And you write just enough based off what you know. And when the company pivots and they now want a different messaging system, they want to be able to send long text messages and pictures where beforehand it was just text, and your provider doesn't support that. Or, some bright spark says, oh, it wouldn't be great if we can have chat as text message, and when they reply back, it goes into the CRM, and your provider only allows one-way text messaging. You can write a new service. You can create a brand new application, and as long as you keep the messaging system, the structure of that message system the same, you can now choose to call your new service. You can come in on a Monday morning and say, right, today we're going to test this, and flip over the messages so that instead of going to the old SMS system, they go to the new one. Keep it running for a couple of hours, watch it in production where you've got resources and people available. Before you go home at night, flick it back to the old tried and tested system. You now have the ability to test and release gradually. And you've got the ability to take the code that changes the most and isolate it and move it into a message-driven platform. Now, in the next video, I'm going to show you some technical solutions of how to do this using RabbitMQ and MassTransit. And I'm going to do a very basic intro, a really clean, simple walkthrough. And I'm not going to get highly technical. Just want to have a play about and show you. And this will form of other videos that we'll do later on. My name is Gary Taylor, and this has been Messaging Systems, and I hope you liked it.